Yes, sir.
Can you see my screen?
Yes, sir.
Thank you for responding. I have observed like there are some problems. This some how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Around 12 problems. Most of you guys did mistake. In UT1, I'm speaking. Maybe like if you also did mistake, please do listen. Initial 5-10 minutes, I'll give hints for this one. So how many of you didn't solve this problem 51? Let me write the problem here so that it will be better for you. How many of you solved this? No response. Everybody solved, huh? Or nobody? I think answer is -9/53. Not sure how many of you solved.
Sorry.
The error problems are not able. No, just few problems. UT error problems alone we will solve. Not everything, I'll just give hints. Sit down. What they told is like they have given me around some 10 problems numbers. They told like majority of the students did mistake in these problems. Please look after these problems. In that, like first one they have given is 51. Like I think something similar to this we solved in PYQs. I'm not sure. Not difficult. Just you can write this one as a hint if you didn't solve in the exam. We will solve this one by assuming cos inverse of 3 by root 10 is equals to alpha, and then sine inverse of, yes please, 4 by root 17 is equals to beta. Like, so you have cos alpha and sine beta value with you. Convert cos alpha and sine beta in terms of tan, right? So now this is nothing but tan of alpha plus 2 beta. You know the value of tan alpha, you know the value of tan beta. Next, it is not difficult one to do. This is just tan alpha plus tan 2 beta divided by 1 minus tan alpha into tan 2 beta. So like maybe you need tan 2 beta using again the formula tan 2 beta is 2 times of tan beta by 1 minus tan square beta. Using that you can solve this problem. If you didn't solve in this one in exam, you have a doubt, I have given the hint. Copy this hint, go home and try again. This time you will get the answer. Clear? So next one they told me is problem number 56. Let me write the problem here. In problem number 56, I think this is problem based on functional equations. They have given f of sin x plus f of cos x, or 2 times, sorry. 2 times of f of cos x is equals to 2x plus 5. Then, okay, x belongs to also given, x belongs to 0 to 1. Then what is f of x actually? Like how many of you solved this one in exam? Anybody? This is problem, like we can say problem based on functional equations. Anybody here solved? No one? Anybody? Not even one solved this problem? So like maybe some idea you will be knowing, no? What you felt after seeing this problem in the exam, how to do this one? What we should do is like this is a linear functional equation. Like linear means power one. That's why linear functional equation. Like if you can eliminate either f of cos x or f of sin x from this, then you are done in this problem. You eliminate and you have like, let's say we are eliminating f of cos x. Then you will be having f of sin x is equals to something. Using replacement property again you will get, right? So like maybe this problem we are doing now, calling this one as equation 1 using the replacement properties of functions. Property number 1, what I will do here is replace x by 90 minus x, which is pi by 2 minus x. Why we are doing this? If we replace, we get like this one as cos, this one as sin. Now we have like f of cos x plus 2 times of f of sin x is equals to, we have 2 times of 90 minus x plus 5 here. Now like you have a second equation. Now like two equations, two variables. Do the manipulation, like elimination method is there, no? Let's say I want to eliminate f of cos x. Multiply with 2 for equation 2 and then equation 1 minus equation 2, if I do f of cos x we can eliminate, then we'll be having f of sin x is equals to something in terms of x. Clear? Let's say I want to eliminate f of sin x from this. Multiply 2 for the equation 1 and then again same subtract it. You will get f of sin x is equals to something. Once you have f of sin x, the replacement property again. I need f of x. For that I need to replace x by sin inverse x. Clear? If I have f of cos x is equals to something, I replace x by cos inverse x. Cos of cos inverse x will be equals to x for all x belongs to 0 to 1. Clear? Understood the hint? Please copy it till here and then go home and solve once. Anybody has doubt in this hint? Everybody understood this one? Online, offline? Sai Nitin, you did this one in exam? You understood? No. Then like again you try. I think I have mentioned earlier to do analysis again. I don't know how many of you did this. This will help you to fill those gaps. Let's say you are scoring 50. By filling the gaps only we can improve for the next exam. Like maybe some other day they are conducting the same chapter. If you didn't fill any gaps, most probably you will get 50 or less than 50. You won't get more than 50. Like you got 50 because like there is a problem in understanding something or there are some gaps or calculation mistakes you did in the exam. Clear? So like one thing I found is like I didn't remember the names. Few students are like not spending 3 hours of the time in the exam. Right? So like why, what is the hurry? I'm asking you, like you plan 3 hours so that you have like free time, maybe Wednesday we are conducting, no? Whenever UT is there, that is on Wednesday, 5 to 8 or like 6 to 9, what is the time you like, you plan that time and then sit for 3 hours. Don't plan something else on that time as well. Clear? You spend 3 hours, then only you are giving your 100%. Or else like, let's say I'm spending only 2 hours, right? I'm giving only 60, 70% in the exam. If you give that much only, according to that only you will get mark. Clear? So then like next problem what I found in this is like 57. It is a problem based on number of functions. Right, everybody copied the hint for 56. So like tell me how many of you did this problem. They have given like set A is equals to 1, 2, 3, 4 and 5. Function f is defined from A to A. Now we need to calculate number of onto functions such that f of I is not equals to I. Right? That means f of 1 should not be equals to 1, f of 2 should not be equals to 2, and so on. Clear? So like anybody solved this one in the exam? You solved it? Oh, good. If you solved it, like what I can say is like my method I am seeing here. I don't know what method you guys did. Like this is a problem which is testing your functions and permutation combination one concept called as derangements. Anybody remember derangements from permutation and combination? What it says? Exactly, or like arranging everything incorrectly. Right? That's what we need to do here. 1 we should not map to 1. 2 we should not map to 2. 3 we should not map to 3. 4 should not map to 4. 5 should not map to 5. Right? So the derangement formula, we have 5 elements. We need to derange 5. Number of onto functions is derangements of 5 elements. D5 is equals to 5 factorial into 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial minus 1 by 4 factorial plus 1 by 5 factorial. One moment. This is plus here and minus here. Alternatively, plus and minus it will change. Right? If I solve this, I am getting answer as 44. Clear? So this is problem based on derangements. Nothing much. Like listen, one more thing you keep in your mind. If number of elements in set A and set B are equal, in that case like number of onto functions or number of one functions are nothing but number of bijections. Number of bijective functions. Just count the bijective functions. 5 elements map to 5 elements. Clear? Normally this restriction is not there. 5 factorial, you have 1, 5 factorial onto 5 factorial bijective as well. Clear? So like understood? If you want, you copy this one as hint. Next one is 59. I don't know why you guys did this one as mistake. I'll write here, don't worry. We need to solve an inverse trigonometric equation, that is tan inverse of x minus 1 by x plus 2 plus tan inverse of x plus 1 by x plus 2 is equals to pi by 4. As I mentioned earlier when I am teaching inverse trigonometric function, just apply tan inverse alpha plus tan inverse beta formula. Right? Change tan inverse to the side. You have like or some equation equals to 1. Solve that equation, you will get x square is equals to pi by 2. X is plus minus root 5 by 2. Only 1 is there in the option, even though 2 are there, back substitute both and check. Clear? Like I think somebody asked this one as a doubt, like I suggested option verification, but like seems trickier, option verification. Root and all there, no? So like directly you do, you are getting it. I tried today. Directly you take tan inverse alpha plus tan inverse beta formula, right? Maybe if you want me to write, I'll write in this way. X minus 1 by x plus 2 plus x plus 1 by x plus 2 divided by 1 minus x square minus 1 divided by x plus 2 whole square. Solve this, your turn. So next is 60. I didn't know why this one. Maybe functions. No, I didn't thought. I don't know what happened. If you attended backup classes, I think I thought some problem like this. Given function f is mapping from real to real. F of x is a cubic polynomial x cube plus x square plus ax plus 6. If you don't know, you write here a range of any odd degree polynomials on set of real numbers if the domain is set of real numbers and range of odd degree polynomials is again set of real numbers minus infinity to plus infinity, right? Since domain is real, a range is also real for the given function. So therefore codomain is equals to range given function is onto. Now the problem is for 1, 1. To show that the given function is 1, 1, we won't use graphical method, we won't use mathematical method. What we use is calculus method or differentiation method. We need to show that either the given function is strictly increasing in the domain or strictly decreasing in the domain, right? You show that f dash of x is greater than or equals to 0 for all x belongs to real, or f dash of x is less than or equals to 0 for all x belongs to real. Clear? So like let us do that f dash. Now f dash of x is equals to 3x square plus 2x plus a here. Right now I have the derivative. They have given that function is bijective. If the function is bijective, it is 1, 1 for sure. If it is 1, 1, f dash of x is either always greater than 0 or always less than 0. Right? See, like in 10th grade, we learned how to draw the equation of parabola. We assume y is equals. Right? F dash of sine is the sine of y. Clear? So, like it is an upward parabola. For an upward parabola, if you are thinking like it can be having two solution. Let's say this parabola has two solution. In that case, like below the axis, right here I have drawn now below the axis, this portion y value will be negative, right? So like if you consider this one, in that case f dash of x is not in, like either greater than or less than, both is there. Above the axis is greater than, below the axis is less than, right? So like remaining cases, if you are considering, it is like just touch and go one case, not touching, not intersecting this one, right? So like we are interested in these two. Why we are interested in these two? Here the minimum value of y is 0, here positive. In this case y is negative. That's why we cannot consider this one. Right, we are saying discriminant is less than or equals to 0. Discriminant is b square minus 4ac. 4 minus 4 times of 3 into a is less than or equals 0. 1 minus 3a less than or equals 0. A minus 1 by 3 is greater than or equals 0. A greater than 1 by 3. So like only one option saying a is positive. Clear? See, like here in this given function is bijective. If the given function is bijective, it should be 1, 1. If the given function is 1, 1, f dash of x should be greater than or equals to 0, one case, or it can be less than or equals to 0. Since it is an upward parabola, I can see that 3 is the coefficient of x square, right? Always less than or equals to 0, not possible. Clear? Like always greater than 0 or equals to 0 is the only possibility. That's what I said. Discriminant is less than 0 and I solved. I got any value of a which is greater than 1 by 3. I considered f dash is increasing, f of x is 1, 1. Clear? Understood? Right? So only one value, that is 5. How many of you solved this one in exam? Well done. Copy this if you didn't solve. Didn't. So next one, I think 61 again, you guys did mistakes, it seems. The fundamental period of the given function f of x is equals to modulus sin x plus modulus cos x. In our book, it is clearly mentioned, and I also thought when we are conducting backup classes for functions, when you are adding two functions f and g, let's say, right? Some are difference also possible. Fundamental period is LCM of T1 and T2. That is true only if f and g are not interconvertible functions, are not co-functions. That has some what you say exceptions. When two functions are interconvertible, like in this case, that point is not valid. Clear? I think I have mentioned that one when I am teaching periodic functions. Here, both sine and cos are two interconvertible functions, right? So like what you guys would have done in the exam is mod sine x period is pi, mod cos x period is pi, LCM between pi and pi is equals to pi. You would have marked pi as the answer, right? But like pi is a period, but we'll agree, but fundamental period is not pi. Clear? So like how to tell that like fundamental period is not pi, we need to check like see the option, no? Option is not there, then we need to think. In option there is pi by 2. If you use pi by 2, if you are doing f of x plus pi by 2 is equals to modulus of sine x plus pi by 2 plus modulus of cos x plus pi by 2. Now we know this is cos x, but here we will get is minus sin x. Modulus will take care of the minus and we get mod cos x plus mod sin x, which is equals to f of x. Now I found out smaller value than pi, which is satisfying f of x plus t is equals to f of x. Therefore, the fundamental period is pi by 2, not pi. Clear? So like it is there in the book. If you see, it will be there. Anybody did mistake here? Mark pi in the exam. Mark pi. So now I thought that is not valid when you have interconvertible functions or co-functions. Clear? You need to check in that case. So like next, I think 63, there is a small typo in that. Maybe because of that, most of you did mistake. In problem 63, we need to find the value of cot. Summation they have given r, it should be n. N is starting 1 going till 30. We have tan inverse of 1 by 1 plus n square. This should be there. I think like in the exam, in the paper, what is given to me, they have mentioned r is starting 1 to 30. Right? If it is r is starting from 1 to 30, that like it is independent. N is independent. We can take tan inverse out. We don't have telescopic series. Either it should be r in tan inverse inside or it should be n in the summation. I think I thought something like this in the class, not discussing again here. So like one more problem I have seen in the error thing. Most of you did mistake. That is like sine inverse x whole square plus cos inverse x whole square. They have given a function like this. The number of distinct integral values that the function f of x can attain is like how many integers are there in the range of the function they are asking. Like, so tell me how you will calculate range of this function. If I remember correctly, I thought two methods. One is completing square method, another is differentiation method. In differentiation method, like you can directly differentiate or you can substitute t is equals to sine inverse x, differentiate it equal to 0, right? We are finding absolute maxima and absolute minima. If you open the notebooks, it will be there in your notebook. I calculated, I got 11 values. Like maybe you will be thinking, sir, we have in terms of pi and pi square. Approximate, no? Pi is 3.14. Pi square is 9 point something. I think we have range as pi square by 8, comma 5 pi square by 4. Right? So like now you approximate pi square is 9 point something. 9 point something by 8 is 1 point something. 5 into 9 point something, if you do, how much is that? 45 point something divided by 4. You get like 3.14 into 3.14. Calculate it into 5, divide by 4. You will get something there, maybe 12 point something. You have 2, 3 going till 12, all the integers. There are 11 integers, distinct integers in the range of this function. Understood my hint? Please try once. Then 68. I think I thought something like this. There is a function which is saying sine inverse x plus cos inverse x plus secant inverse x. It is similar to the problem in step 2. Find the domain, no? Domains, common domain if you take. Domain of the function you will get is only two values. -1 to +1. In the domain, if you have two values, most probably in the range you should have either two values or less than, not more than two values. By seeing this, you can discard like option 2 and option 3. It is interval. How I am saying it, like very easy, like sine inverse x and cos inverse x is defined only if x is there in between -1 to 1. Secant inverse x is defined only if x is greater than or equals to 1 or less than or equals -1. Clear? Only two values will work here. Then like there is a problem here. N of A is equals to 3. Then number of relations which are both symmetric and reflexive. Number of relations which are both symmetric and reflexive. How many of you did? Anybody did? There is a formula to do this. Divided by n. 2. If you don't know the formula, numbers are easy only. We can directly do without using the formula as well. Like I'll consider set A as 3 elements, that 3 can be 1, 2, 3. Now like relation means it is a subset of A cross A. In A cross A you have 1, 1, 2, 2, 3, 3. These three are similar order pairs. Next is 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, and 3, 1. So like 9 order pairs you have. Since the relation is symmetric and reflexive both. Now one by one you count. Any order pair, if I take from these three, it should have only one chance, that should be there in the relation R. Then only it is reflexive. Otherwise, it cannot be reflexive. Clear? All three elements, all three order pairs will have one chance each. Now, remaining, I should talk about pairwise, not individually. Like if 1, 2 and 2, 1, if I am considering as one pair, this is second pair and this is third pair. So like first pair can be there in relation R. If you keep it, it is both reflexive and symmetric. Can be outside of relation R as well. Right? So that's why we write 1 into 2 into 2 into 2. There is no harm even though you are not keeping this pair in relation R. Right? Only one you are keeping, then only it is not symmetric. I am talking pairwise. That is 2 cube is 8. Right? Maybe few of you are getting bored. Then if you have any other individual doubts, you ask me. afterwards. We'll continue with matrices. We are in matrices. I think like this was the last problem we solved. We have seen about this orthogonal matrix, if I remember correctly, right? So after orthogonal matrix, we have another two matrices which was not there in the portions. Maybe like they might ask us, for that we are seeing. Quickly we will see about it and we will go about remaining concepts. Like we have symmetric and skew symmetric in real matrices. Like that in complex matrices we have Hermitian and skew Hermitian. Right? So let us see that two types quickly and we will move forward. Put one small subheading, Hermitian matrix. I think somebody from state board would have seen this. No? So like, what is Hermitian? It is very similar to symmetric. If A transpose is equals to A, that is symmetric. Like here, instead of transpose, now the matrix entries are complex numbers. We will do first conjugate, then we will take transpose. The transpose of conjugate matrix is equals to the matrix. Then we will say that one as a Hermitian matrix. Right? So like let us write the definition. The square matrix if A conjugate transpose is equals to A. So like this A conjugate transpose, we will denote in this way, that is A to the power theta is equals to A. If A to the power theta is equals to A, that is Hermitian matrix. Let us see some basic examples for Hermitian matrix. A is equals to 1 I minus I and then right. So like how to tell whether it is Hermitian or not. For that first we need to take conjugate of the matrix, right? Conjugate of the matrix A conjugate is equals to, conjugate means do conjugate for each and every element, that much only, right? So this will be equals to conjugate of 1 is 1 only, I conjugate is minus I conjugate is 1 and then 1 conjugate is 1. Clear? So like now we are doing transpose of this one. A conjugate transpose. This is also equals to A transpose whole conjugate that we are naming as A power theta is equals. If we do transpose, we get 1 I minus I and clear, which is same as A. A power theta is equals to A, therefore it is Hermitian matrix. We can give one example as well, but like definition and this one will do. Right? Understood? Next is skew Hermitian, similar to skew symmetric. I'm scrolling up. Anybody writing this? Anybody writing? All right. Next is skew Hermitian, similar to skew symmetric. Sorry? You want, one moment. See, like, listen. When you are taking conjugate of a matrix, maybe this side, let's say matrix A is equals to Aij, not necessary to be square matrix for the conjugate. When you are taking conjugate of A, that will be equals to conjugate of Aij, that's all. Matrix conjugate is conjugate of every element. All. Nothing else. Clear? Any doubt? So skew Hermitian matrix. In skew Hermitian matrix, like we say, the square matrix. I conjugate is minus I, no? Huh? Modulus is 1 dear, not conjugate. See, like 1 plus I is there. Conjugate is 1 minus I only. No? We replace sign in front of I. All of that is conjugate. See, like geometrically, if you see, conjugate is you are finding image of the point with respect to the real axis. I means 0, comma 1. Image of 0, comma 1 with respect to real axis will be 0, comma minus 1. That is minus I. If a to the power theta is equals to minus, let us take one small example. See, like if you have doubt in taking conjugate, first listen. Right? A conjugate will be equals to. When you are taking conjugate of a matrix, just do conjugate of each and every element. Conjugate for I is equals to minus I. This will be 1 minus I. And then you will have minus 1 minus I. 0 conjugate is 0 only. Clear? Still some doubt is there? Say no. Maybe if you want A plus IB is the complex number. Conjugate of this complex number is A minus IB. That's what I'm doing. Right? Nothing much I'm doing here. Complex numbers you didn't attend, or you didn't see at all. Right now, transpose of this one, which is equals to A power theta. A power theta, if you are doing like you have minus I, minus 1 minus I, 1 minus I, 0. Like let us take minus 1 common from the matrix. When you are taking anything common, you should take from each and every element of a matrix. This is minus 1 into I, 1 plus I, minus 1 plus I, 0. So like I can say that a to the power theta is equals to minus a, therefore it is a conjugate. Sorry, a to the power theta is minus a, it is Q Hermitian matrix. Clear? So like we have a matrix here similar to orthogonal, that is called unitary matrix. In orthogonal, you will have A into A transpose is equals to identity. Here it is A into A power theta is identity. Like this much will do. More detail is not required for you, right? If they ask anything, maybe if you want 2 note points, we can write here. That is about diagonal elements. We can show that as well. Can I scroll up? So like the diagonal elements of a Hermitian matrix are purely real or zero. For skew Hamilton, it is purely imaginary or zero. This much only we can write. Next, like we will see about elementary operations on a matrix. This was initially part of NCERT, but like they have removed in recent rationalization. Using this elementary operations, we can find inverse of a matrix. But like in next chapter, if you studied matrices, you will be knowing that we have some other method to find inverse of a matrix. That is like we will find inverse by adjoint. Clear? So like this method, if you like it, like you can use like it is there. Maybe they might ask problem, for that we are learning. Right. Can I scroll up? First, we will learn what are the operations we can use. Then we will learn how to use that one to find the inverse. Right. So scrolling up, please put one small subheading. Elementary operations. Elementary operations of a matrix. Elementary operations of a matrix. Like these are all basic things. What operations and all we can use for a matrix, right? So like similar to this, we will also see in determinants as well. So these are all basic operations which we can apply for a matrix. It is not necessary the matrix is square. For any matrix, you can do that, right? So like first one, like listen carefully. We can interchange any two rows or columns of a matrix. Let us understand, like every time we won't write interchanging rows and columns. There is a method, like so we represent that. We represent this operation interchanging ith row, maybe in bracket column, with jth row in bracket column, Ri double implies, you remember, no, something like that, and Rj. So like this symbol says that row I and row j are interchanging. Clear? So like double implies means interchanging thing. Please remember. Like similarly for column I, we can interchanging with column J. Like let us take one example to understand this elementary operation. Like let us take one small square matrix. A is equals to 1, 2, 3, 4. So like for A, like you have 2 rows and 2 columns, right? Always remember like it is 2 rows and 2 columns. Now here I am writing R1 has been interchanged with R2. When I am doing operations on rows, I cannot do simultaneously operations on columns. And I cannot write C1 interchanging C2. First finish this and do for column whatever you want. Right? When you are applying the operations, the resultant matrix is called as similar matrix to A, not the matrix A. We use similar symbol here, similar triangles you have seen or something like that. So like now 3 and 4, 1 and 2 is what you have the new matrix. This matrix is similar to matrix A. We got this matrix by interchanging row 1 and row 2 of matrix A. We will also write here, maybe like column 1 is interchanging with column 2. In this case, like again similar matrix you will get. Now this is 4 and 2, 3 and 1. If we observe one thing, when I'm making change in a row, I'm writing row wise. When I'm making change in a column, I'm writing column wise. Please make that one as a habit. Clear? Understood? Like first elementary operation we learned here, for like we can interchange any 2 rows or any 2 columns of a matrix, right? That one we represent interchanging rows. R1 and R2 we will write R1 interchanging with R2. Column 1 interchanging with column 2. Clear? Understood? Any doubts? Right? This is the basic thing. Why we do these all things. Maybe to find rank of a matrix, maybe to find inverse of a matrix. Clear? Can I scroll up? Everybody copied this? Understood? This is the basic thing. Right? 2 operations, both like one I did for rows, another I did for column. Like we solve some problems, then you will understand more. Like second operation. We can multiply a row or a column, maybe a we move or column with a non-zero scalar. So like how to represent that we are writing. We represent multiplying every element of ith row or column with k as ri change as. Like two sides means interchange as, one side means ri change as k into ri. So like here k is a non-zero scalar, k cannot be a 0 1. Similarly, column 1 I can write column I change as k into column I. Clear? So like k is a non-zero scalar. We are allowed to multiply with a scalar for the entire row or for the entire column. Like let us take one example to understand maybe the same matrix 1, 2, 3, 4. Let us take A is equals to 1, 2, 3, 4 we are taking. And then like we are applying a row operation here. A row 1 we are changing as 3 times of row 1, right? Now the similar matrix we are getting for A, this is like 1 into 3 is 3, 2 into 3 is 6, and then 3 and 4, right? If I want, I can also write here column 1 is changing as column 1 divided by 3. Not only multiplication, division is also allowed here. Now I can write here this is similar to 3 by 3 is 1, 3 by 3 is 1, 6 and 4. If you want, we can also write column 2 is changed as like there is common, no, I can take that. Right? Understood? Multiplying or dividing the entire row or column with a non-zero scalar is allowed. Right? Here we should take a note here. Normally in real numbers, we will add something on both sides, subtract something on both sides. That is not allowed here. Adding or subtracting a scalar to a row or column is not allowed. We are not allowed to write row 1 change as row 1 plus 2, row 1 change as row 1 minus 2, and so on. That's what this second note point here says. Sorry, note point here. Everybody understood? Right? We cannot write column 1 change as column 1 plus 10. It cannot be a scalar. You cannot. Right? See, like very simple. The inputs of matrices are vectors. Like you cannot add I cap plus j cap plus k cap plus 10. Not possible, not defined. Clear?
So
No,
these are all allowed because the determinant is what.
determinant might change.
So on what basis are we getting here?
No, like I'll teach you about similar matrices. Determinants may change when you are doing this multiplication. In properties of determinants, I'll teach about what operation you can use to expand it so that the value of determinant changes. The second one, if you are doing multiplying something at determinant like 2 you are multiplying to row 1, determinant becomes twice.
What defines the
Rules we are reading. Basically, these are all rules which you can apply. Clear? The third operation, we can apply, we can add the elements of ith row or column to the corresponding elements of jth row or column multiplied by a non-zero scalar. See, like scalar alone you cannot do, but like what you can do here is, let's say you are making a change in ith row. So like you are writing Ri changes Ri plus K into Rj. What you are doing? In ith row, first element you are adding to jth row, first element into K. Right? You can also write Ci change as Ci plus K into Cj, like, and so on. If it is order 3 matrix, you can use all 3 columns, all 3 rows as well. Let us see one example to understand this one. So for this, I can write here column 2 changes column 2 plus 3 times of column 1. We are making change in column 2, right? After making any change, what you get is similar matrix. Similar matrix na like determinant may not be same, may or may not be same. Like here in this case, you will get same determinant, but like there are something else other than determinant which will be same. Clear? So like there is something called characteristic polynomial will be same. Eigen, they will say roots also same. Eigenvalues, eigenvectors will be same, right? So like these all things will be there that we will discuss only after determinants, right? Here there is a change in column 2, so writing column wise 1 and 3. What we are doing? We are doing 2 plus 3 into 1. So like this is 2 here, and then like for this 2 we are plus 3 into 1 we are writing. Right? Similarly, 4 plus 3 into 3 we have. Like now, how much is this one? This is 1, 3, 2 plus 3 is 5, 4 plus 9 is 30. Clear? So like we have learnt 3 operations. One is interchanging any 2 rows or any 2 columns. Again, interchanging 1 row and 1 column is not allowed. We cannot do that. Clear? Row 1, you cannot interchange with column 1. Row you are interchanging now, you should interchange with another row. Column you are interchanging, you should interchange with column. Right? So like row 1, you can multiply for row 1 to any scalar to that other than 0. Right? Again, like corresponding elements of row 1 can be added to the corresponding elements of row 2 multiplied by a scalar. Clear? I can also write R1 plus R2, R1 minus R2 and so on. Understood? Like after learning the basics of the operations, now we are going to learn how to find inverse of a matrix. Right? Everybody understood that 3 basic operations? Let us quickly write the definition for inverse of a matrix. Inverse of a matrix. Inverse exists only for a square matrix, not all square matrix. Let A be a non-singular matrix. See, like for rectangle, you won't be having singular, non-singular, it should be square. The matrix A is said to be invertible if there exists a matrix B such that AB is equals BA is equals identity matrix. Like if you have a matrix B where AB is equals to identity matrix, in that case, B is nothing but A inverse. Or you can also write B inverse is nothing but A. Clear? All matrices are not invertible, first of all, the matrix should be square, then you can find inverse. Second thing is like the square matrix should be a non-singular one, determinant is non-zero, then inverse exists, right? Now let us solve one problem to find the inverse using inverse of a matrix by elementary operations. So like example number 17 they have given, that one only I'm considering. In example number 17, we need to find inverse of the matrix A is equals to 2, 4, 1 and minus 1. You can see the determinant of the matrix is non-zero. It is a non-singular matrix, inverse exists, right? Inverse of the matrix we can calculate, right? Here again there are some rules, right? To use a row operation, like we are allowed to use either full row operations or full column operations in the process of calculating inverse. Clear? So like to use row operations, we'll write A is equals to identity matrix into A, right? Like we won't substitute right hand side A, left hand side A we will substitute. This will be like 2, 4, 1 minus 1 is equals to 1, 0, 0, 1 and then matrix A, like this I keep, right? So like now I'll apply the row operations and I will make this matrix as identity matrix. If I'm making this matrix as identity matrix, I have I is equals to a matrix B into A. From the definition of inverse, I can say that B is inverse of the matrix A. Now like listen carefully. In the process of making this 2, 4, 1 minus 1, what you say, identity matrix, there are some certain rules or certain patterns we'll follow here, right? In identity matrix, this element is 1, right? So like I want to make this element as 1, how can I make? I cannot subtract 1 from row 1. I cannot write row 1 change as row 1 minus 1. What I will do, I will write row 1 change as a row 1 divided by 2, 1 by 2 into a row 1. If I do that, I have 1 and then 2 here. If I'm making any change here, I'll make here as well. Keep that one in mind. So like first elementary operation we are applying, that is a row 1 changes a row 1 divided by 2. That is 1 by 2 times a row 1. Now like we have here 1, 2, 1 and then minus 1 is equals. It becomes 1 by 2, 0, 0 and 1. There is a matrix A. Hope everybody understood the basic elementary operation what we did, the initial one. Next, like once you created 1 here row wise, like you try to create a 0 here, right? See, like not only here, you can do here as well. Anything is same, right? Maybe here creating might be easier. We will do that. How to do that one? Like I want 0 here. If I want 0 here, in this row I am making change. So what I will write? A row 2, this is second row, change as a row 2 minus row 1, right? So like if I write here, a row 2 change as a row 2 minus a row 1. So like what do we have? We have, there is no change here, 1 and 2. This is 1 minus 1, right? 1 minus 1, 0. Now like how much I will be having here? It is minus 1 and minus 2, which will be minus 3, right? So in the same way, this side as well, you have 1 by 2, 0, minus 1 by 2 and 1. 0 minus 1 by 2 I did, and then I have a matrix A over here, right? So like I created 1, I created 0. Next, like I can create 1 as well here. If I create 1, how to create? For that, we will divide by minus 3. Right? Minus 3, if we do like row 2 is changing as minus 1 by 3 into row 2. Like now we have like here 1, 2, 0, 1, and then like this side we have is equals to 1 by 2, 0, 1 by 6, and 1 by 3. There is a matrix A we have with us. Right? Now 1, 0, 1. I need to create 0 here. So like how to create 0 there? Like we can write like 2 is there. I have 1. 2 minus 2 into 1 I can write. So that will be a row 1 changes a row 1 minus 2 times of row. So like this is there is a change 1 minus 2 into 0, that is 1 only. I'll get 0 here, 0 and 1. So left hand side, the moment I got identity matrix, I'll stop here. So like here 1 by 2 minus 1 1 by 3 I'll get, and then this is minus 2 by 3 I'll get here, 1 by 6 and 1 by 3 I have. This is matrix A, and then like simplifying more, we have 1 by 6 minus 2 by 3, 1 by 6 and 1 by 3 into matrix AB. So now I can write that therefore A inverse is equals to 1 by 6 minus 2 by 3, 1 by 6, 1 by 3. Right? So like little trickier only. Before it was there in NCERT, maybe in NCERT exam they can ask. Find inverse of a matrix using elementary operations. That time it will be helpful. Anyway, one method is there, we learned it. This will help us in determinants. Clear? So like the basic elementary operations, what we are doing on matrix, that will help. Any doubt in this? Anybody writing this part of this slide? Anybody? Then copy. Is this okay? You are copying before one, no, right? Then write, please. See, like same thing, if you want to write in column like you want to use column transformations, elementary operations on only columns. Like here we wrote A is equals identity into A, just interchange identity and A, right? A is equals A into identity. Right hand side, you keep A in the same way. Identity you substitute, A you substitute, apply operations on both sides. You are creating identity is equals A into B, that B is your inverse of a matrix. Order 3 also we can do in the same way. One we'll do for order 3 as well. Where here? Here. Here minus 1 by 3. Then one moment. If it is minus 1 by 3, then our calculations are incorrect. Yep, this is minus 1 by 3. Okay, R1 changes, then this becomes plus 2 by 3. This is minus 1 by 3. My dear student, there is a small correction. I did mistake earlier. Now I think it is correct. Thank you for correcting me. I'll come there. Here. What did you did there? Determinants or matters? 40. Orthogonal matrix idiom. If this is A square will be cos 2 theta minus sin 2 theta, sin 2 theta, cos 2 theta. Q will be 3 theta minus 15 minus 15 theta. You do a square. You will get cos 2 theta minus sin 2 theta, sin 2 theta, cos 2 theta. A cube you do 3 theta, so you will get. A for minus 50 you will get is minus 50 theta everything. Substitute theta pi by 12. Cos is even function. 50 into theta. Sin is odd, so plus minus sin. What is theta? Pi by 12. So 50 into pi by 12. 620. 25 pi by 12 is pi by 6. 4 pi plus pi by 6 quadrant plus. Are we done? Now, let us take one example. Again, this is the example from book. I might use something different operations. Example 18, they have given row. I'll use column here to find inverse. Can I scroll up? Example 18. See, listen to me carefully. In determinants, again, I will tell this one. If it is a nth order square matrix, in that you can apply n minus 1 transformations at one time. If it is second order square matrix, you can apply one transformation. If it is third order square matrix, you can apply two, right? The two should be on both rows or both columns. You cannot change one row and one column simultaneously. Keep this one in mind, right? So they have given matrix A is equals to 1, 2, minus 2, minus 1, 3 and 0, 0, then minus 2 and 1. Please be quiet. So they are using row operations, I'll use column. For column, as I mentioned, I'll write A is equals to A into identity matrix. Right hand side, I won't substitute A. 1, 2, minus 2, minus 1, 3, 0 other. 3, 0. What's wrong? Please quiet. Right? So what I'll do, I want to make 0 here, 0 here, right? How to make 0? I'm applying two things simultaneously. Listen carefully. Both I am applying based on column 1. Column 2 changes. Column 2 minus 2 times of column 1. What is happening? 2 minus 2, 0 we are getting up. Similarly, column 3 changes column 3 plus 2 times of column 1. Listen to me carefully. If I apply C2 changes C2 minus 2C1. If I am writing C1 changes minus 2 times of C1 plus C2, that is not allowed. Same thing only you are applying there as well. That is not. Keep that one in mind. So quickly tell me making change in the column. So writing column wise 1 minus 1 0. So you will get 0 here. 3 plus 2 is there. 3 plus 2 is 5. Minus 2 I'll be having here. Next it is like 0. After that, minus 2. Next we have what? Next it is like 1, I guess. Same thing here as well. Minus 2, 1, 0. Right? There is 5 here. How to like listen carefully. One more thing you should keep in your mind. Please don't make noise. In the process of making this one as 1, please don't spoil the 0. If you're spoiling the 0, then again you should create 0 then, right? So like how to make here 1? We can write that column 2 changes column 2 plus 2 times of column 3, right? So like column 2 changes column 2 plus 2 times of column 3. So like now 1 minus 1 0. So like 0 plus 2 times of 0 is 0 only. Clear? If I use this one, what happens? I can also write column 2 changes 4 times of column 1. What happens? Here you will get 1, then what about here? 4 you will get. So don't spoil 0 there. It is 0. This is 1 here. So then next I think I am getting 0. This is bonus for us. Clear? Minus 2 plus 2. There is no change here. 0, minus 2, 1. One, 0, 1. So this is minus 2 plus 4, 2 here. 1. So if we see carefully, 0s is done, 1 is also done. Like listen, while creating 0 here, please use column 2. Why? Because this 1 you should not spoil. The 0 you should not spoil. Right? So same thing, creating 0 here, please use column 2. So column 2 we are using and we are writing uh, column 1 changes column 1 plus column 2. And then similarly column 3 changes column 3 plus 2 times of column 2. So like if we do that we have 1 plus 0 1 minus 1 plus 1 and then 0. 0, 1, 0. So like now it is 0, 0 and you should get 1 for sure. Is equals A into. Now it is 3, 1, 3 we have. Then what do we have? We have like 2, 1, 2 we have, right? So C3 it is like 2 plus 4, 6, 2, and then like we have C3 5. So can somebody check is this the inverse? 3 2 6, 1 1 2, 3 2 5. One mistake we got. We are not having 3 here, we are having 2. Why we got that mistake? 1 1 2, 3 2 6, everything perfect. 1. It is 1 1 0, right? If it is 1 1 0, then it is. This is inverse. Like anybody copying this? Quickly copy it. What about this part? Don't want to. So then please wait. Let me mark attendance. After marking attendance, you guys can leave. Please wait. Loga Prasanna Ganapati is there online. Offline, I cannot.
Yes, sir. Present, sir.
Present, marking present. Roslyn,
Present, sir.
Chabarish Veeranan. Yes, Gautaman. Sushant is there online. Yalini. So anybody didn't punch downstairs, offline students? What's your name? Siva Santosh. Initial is there? Yes, sir. It is showing present only. Then that's all. Then offline students can leave. If you like anybody writing this, no. I think online students you can also leave.
Thank you, sir. Thank you, sir.
Hmm?
Thank you, sir. Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you.
So we started it back up first, so for like after operations.
I am little busy.
Okay. I just wanted to confirm that we can. Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir.
Do you have problems in complex number?
No, sir.
Thank you, sir.
Very.
Online students, some doubts?
Thank you, sir.
Thank you, dear. Hmm.
It is coming from school.